Hello, this time we are going to have another problem. This time it is a 3D. It is about the regular tetrahedron. So we have to find the face area, the surface area, and the volume. This is a 3D figure, so it's a little complicated, but we are going to slowly go through it. And I'm going to show an animation before we start to solve the problem, to make you understand these faces. There are 4 faces here. They are all equal, and since it's a regular tetrahedron, all sides are the same. They called edges or lengths of 6. So it is equilateral triangles. So if you look at the net here, you see these are the 3 parts that are folding and unfolding, and we have the base also, which is the same. So total we have 4 face areas. So for each of these we are going to calculate the area. One of them is called the face, so the face area is the area of that triangle. So we are going to use this information we have and solve the problem. If we look from the bottom of our 3D, we have an equilateral triangle, and the point at the center there is corresponding to the junction of these 3 folding parts on the top. So if you look at the right side, the H is the distance from O to D. There are D is pointing towards us as we speak because we are looking at the bottom. So if we call A the edge or the side here, and X that distance from O to the vertex, and on the right side we will see the H is the height we will use to calculate the volume, and the X will be the X we will be finding on the left side. So let's go. So the first thing is to find the face area. So to find the face area, we are going to look at our equilateral triangle, which side 6, or every side, everything is 6. That means the angles are 60, 60, and 60, and if we divide them by 2, we get 30 degrees, 30 degrees. And then at the center there we have 120 degrees. So we have 3 ways to calculate the face area. We are going to use the first way, the Heron formula. Since we have the 3 sides, each one is 6, we can use the Heron formula to calculate our face area here. So the Heron formula bases itself on the 6 sides, on the 3 sides, and incidentally here all 3 sides are the same. So if we find the semi-perimeter, it will be 3 times A over 2. Otherwise, A plus A plus A over 2 is 3A over 2. And then, easy to find the face area using the Heron formula. We know that the area per Heron is equal to square root of the semi-perimeter times semi-perimeter minus first side times semi-perimeter minus second side times semi-perimeter times third minus third side. But here, first, second, and third sides are all the same, and they are all A. And S is 3A over 2, and S minus A is A over 2. So we will have 3A over 2 times A over 2 times A over 2 times A over 2. Very good. So if you look at the denominator, we have 4 twice, and a squared twice, so these are going to go out. So square root of 3 over 4 times a squared. This is the formula. How about using the second method? We have the angle 60 degrees and the sides 6 and 6. So the area is half of sine of the angle between the two sides, which is 60 degrees, times the two sides. But here two sides are the same, a times a. So we know that sine 60 degrees is square root over 3 over 2, and then times a squared. That makes it square root of 3 over 4 times a squared. How about using the third method? The third method is actually for me the best. If you don't know the formula, we look at every face, we take it half of it, we try to find the height of it, and we know that the side is 6, and half of the side down there will be a over 2, and then we try to find the height of the triangle h1. So what we find is h1 squared is equal to a squared minus a over 2 squared is equal to a squared minus a squared over 4 is equal to 4 a squared over 4 minus a squared over 4 is 3a squared over 4, and that is the height. And now the area is half of the base times the height. So half of the base is a times height is h1 here is, so we get, okay. So once we have that, we can do some simplification here. So 1/2 of a times square root 3 over 2 times a, because remember the value up there is h1 squared, we have to take the square root of that. So we get the area is equal to square root of 3 over 4 times a squared. Also, all three situations, all three methods gave us the same result. Since in our situation a is equal to 6, we are going to plug in, and then we answer to the first question. So the face area is equal to square root of 3 over 4 times 6 squared. That means 36 over 4 is 9 square root of 3. Very good. So to find the surface area is just adding these 4 triangle areas, face areas. Otherwise it is 4 times 9 square root of 3 is equal to 36 square root of 3. That will be our area, surface area. So that answered the second question. So of course unit squared. Now we go for the volume. Volume of this is 1/2 of area of the base times h. A0 is equal to square root of 3 over 4 a squared. That's the face area of the base. Now we have to find h. Look at the sketches. To find h, we have to find x first. Using the second, the right side, we will find the value of h. So if we look at the left side, we can say a over sine 120 is equal to x over sine 30. That helps us find x. X is equal to sine 30 over sine 20 times a. So 1/2 times square root of 3 over 2 is equal to a over square root of 3. So that is the value of x. So we have on the right side x now at the base, and we have our h, and we have a. So we have to find h. H is the height of this figure, this 3D. This is the one we want to find here, right? So h squared is equal to a squared minus x squared. So it is equal to a squared minus a over square root of 3 all squared. So that makes it a squared minus a squared over 3. That means 3a squared minus a squared over 3. That makes it 2 squared a squared over 3. So then we can find h. So we pull out h. This is square root of 2 over 3 and times a. Now we know that the volume is 1/3 of area of the base of face area times h. So we plug in. So we say it's equal to 1/3 of square root of 3 over 4 times a squared times h is equal to square root of 2 over 3 times a. So we make the calculations. We have 12 in the denominator, square root of 3 merging with square root 2 over 3, we get square root of 2, and we get a cubed. A squared times a is a cubed over 12, now times square root of 2. So if we multiply numerator and denominator per square root of 2, we get a cubed times 2 over 12 times square root of 2, and we simplify, we get a cubed over 6 times square root of 2. So finally, if we plug in a is equal to 6, we will find our volume of the regular tetrahedron is equal to 6 times 6 times 6 over 6 square root of 2. So we simplify, we get 36 over square root of 2. And if we rationalize this, so 36 square root of 2 over 2. That makes it 18 square root of 2. And this will be in cubic units. Thank you for watching, and I hope this 3D was interesting to you, and we will get more of these later. Thank you.